this piecewise function graph, I have three different pieces. My top one here, which I'll do in green, my second one, which I'll do in black, and my third one, which I'll do in red. And remember, from top to bottom, we're always moving from left to right. So the green one is going to be the first one on the left, the black one will be x values in the middle, and the red one will be x values farthest to the right. So let's start with the green one. I have x plus 4 cubed. The parent function, you have to think about the parent function, is x cubed. And I know that the graph of x cubed is a squiggly thing that looks kind of like that. You should know your parent functions. But if I was to just graph it over here, 0, 0, 1, 1, 2, 8, well, 3 is way up here at 27. Negative 1, negative 1, negative 2, negative 8. So you kind of see I have this skinny, narrow, squiggly thing that looks kind of like that. Okay, so let's see what part of it we are at with this particular top piece right here. I'm going to make myself a little T. And I'm going to have my x values and my y values, which are x plus 4 cubed. And I know I want less than or equal to negative 3. So I may as well just start here at negative 3. So negative 3 plus 4 is negative 1. When I cube negative 1, I get negative 1. Well, let's try negative 4 since I'm going to the left. Negative 4 plus 4 is 0. Well, when I cube 0, I get 0. And let's try negative 5. Negative 5 plus 4 is negative 1. Is that right? I made a mistake. I made a mistake right here. Negative 3 plus 4 is positive 1. When I cube it, it's positive 1. I'm sorry. I hope you didn't get too messed up by that. Negative 5 plus 4 is negative 1, and when I cube that, that's where I get negative 1. And let's see if we can't add an extra one down here or so. Negative 6 plus 4 is negative 2. I cube negative 2, I get negative 8. So what is this graph looking like on my graph here? Well, at negative 3, I have positive 1. At negative 4, I have 0. At negative 5, I have negative 1. And at negative 6, I have negative 8. So I think I am kind of like in, let's put it in a different color, in this portion of the graph, it's just moved over a bit. So that looks like this. And it is less than or equal to negative 3, so that point is included. And this is going to keep going down as far until negative infinity. So that's my first piece. My second piece says negative absolute value of x, but only where x is equal to negative 1. So when I make my little t right here, I have x, and my function, my y value is negative absolute value of x. So where x is equal to negative 1, I would have negative the absolute value of negative 1, which means at negative 1, well, this absolute value of negative 1 is positive 1 minus, so it's negative 1. So I have the point negative 1, negative 1. So that is negative 1, negative 1. Just that single point. That's the only part that I have there. And then the last piece is the graph of x, but that's where x is greater than or equal to 0. Well, I know the graph of x is just a diagonal line with a slope of 1, y-intercept of 0. So this is the graph of x. And I only want it where it is greater than or equal to 0. So that's a pretty good representation here of my function. Let's see if we can figure out the domain of this function by looking at the graph. So my green piece here that is starting, it's going to keep going down forever and keep going farther and farther to the left. All the x values from negative 3 that way are included, but then it stops here at negative 3. So my domain for that piece is going to be negative infinity. Let's make it look like a negative infinity instead of some weird creature. Negative infinity, and it goes to negative 3. And negative 3 is included. And the reason I kind of break it off there is because I can see that I have a gap in my domain right here. From negative 3 all the way up to negative 1, I have a gap. And I can kind of see that right here. I go everything less than negative 3. It doesn't say anything about negative 2, and it just kind of goes all the way right over there to negative 1. So I have negative 1 is included in my domain, but it's only a single dot. That's all it is. So union negative 1. And then I have another gap between negative 1 and 0. So I'm going to I did another union sign there. So I start again at 0, which is included. And now it goes all the way to infinity. So if I was to write my domain in one single line, which I really should, my domain is negative infinity to negative 3 included, union negative 1, union 0 included to infinity. That would be my domain. Well, let's take a look at the range. I'm going to do it over here. Again, on my green function, I am going all the way down here to negative infinity. So I'm starting down at negative infinity. And my green function carries me all the way up here to positive 1. So the fact that there's a gap in the range and the y values from this point right here to there, and from this point right here to there, it really makes no difference because I've got it all covered here with my green function. The green function has all those y values up to positive 1. And then my red function started at 0, and it just took off and got all the y values all the way to positive infinity. There are no gaps in the y values. So that goes from negative infinity all the way to positive infinity. That is my range on this problem.